Okay, we're live. Good morning. We just set up last thing over here and we can start shortly. Okay. Yeah. I wanted to show we're gonna start today with the file from last time, the one with lists and data tree. So we're gonna touch on that a little bit more. So try to find that file, please, and we can start from there. So here we go. I hope it stays on the stream. Yeah, it seems like it's there. Perfect. And we're gonna focus on this part where the data tree starts. That's an important part of the whole thing. I hope I have an example here. Yeah, good. And this is good. Yeah. So I think it's now just 3 students, so we have to wait a little bit, but we'll start in a few minutes. So maybe time for a tea or something like that. Going to the toilet before we start. Still have time to do that. Make this bigger. It doesn't work. Okay. 6 students. That's better, but I am hoping for a little bit more, so we're still waiting. Seven. Okay. Okay, maybe in the meantime, how many of you had time to go through the chapter about data tree in the book? How many of you actually got time to look at it at least? Please write it in the comments because that's important. Good morning. Okay, 10 people connected. Cool, thank you, Camelia. Yeah, okay, some did, some did not. After this lesson, that you definitely have to do it. If you don't find everything super clear, that means you need some other way of explaining the whole thing we're gonna touch on today. And like we're gonna do a big thing today. So this is the topic which separates the beginners from the pros. If you can do things with data tree fluently, you're a pro user of Grasshopper. And this is important step. So if you get confused, like right now, just you can save that file, annotate using this this pencil tool here. Just use that to annotate what is your problem. Just put it directly into the file and then send that file to me. I can help you individually, but first, before you ask for help like this, please make sure that you've at least read the chapter, because it's they're explaining it in a different way that I'm gonna do, it's today, and I believe that's good for like getting more sources of data. And I'm gonna reference some cool other tutorials on YouTube as well. But this is a big topic, and you really have to understand this. So in order to be able to work in Grasshopper fluently. So I can see 13 people. That's still less than last time, so maybe we still have to wait, but I don't like waiting. Try to be on time next time. It's 5 minutes, so we're gonna do 3 more minutes, and then we're gonna start. Um, but make sure if you're sending a file, make sure that if you have some kind of curves in the beginning or something, maybe there's no curves. Okay, like in this example over here, if you have some curves like this in the beginning, if you don't send me the Rhino file, this is gonna be orange. It's gonna look like this. And if I do it like this, everything disappears. So please don't send files which don't have the data internalized. You have to right click and set like click on internalized data. Okay, so like this, internalize data. It's important. Okay, just 1 more minute, then we'll start. Oh, somebody just dropped out. It's 12 now. Okay. Well, okay, let's start with that file we've been exploring last time. Let's jump just below this dispatch thing. That's where we ended last time. And there's this new part with the graph tree component. I hope you all have this file as well. And let's check out this little thing which is happening over here. In here we have a list like we've used to. There's Anne, Buck, Cecil, Dick, Elizabeth, Frodo, and these guys, and everybody has they have their own indexes over here. So Anne is on index 0, Buck is on index 1, and so on. And if we use graph tree, which is actually the same thing if you right click and use this graph option where this little arrow appears, that's the same thing. This component does the same thing. If you do that, check out the list. Something happened to that list, and also the cable is different. See, the cable is now dashed, and that means there is not just one list like this. There's many lists, and over here you can see that first list is named 00, and it has only one index, and it holds only Anne in there. There's Buck, there's Cecil, Dick, Elizabeth, all of the people in the initial list. But the thing is, they are separated into separate lists. And that's why the cable is dashed, because they're separate lists. This is what happens many times. And the opposite of graphed, like this, is flattened. So sometimes you can have arrow going down, that's flattened tree. And that's the same thing as this component does. So let's check out the output. It gets back into one list. The name is 0 again. Is this clear? Is it like, there's many lists. They're on top of each other, but you can see the name of the list and the indexes of that list. And there are two operations, graphed and flatten. So sometimes you need to do this in a very intricate way to get some data flowing together, and we're gonna touch on this today on many different occasions. So there's gonna be like many different cases where you can have this kind of problem, and I hope by playing with these different examples we're gonna understand how to work with data tree. So if this is clear, we can continue. So was gonna be funny here, and in the example like right below, there's our list, and we're using this concatenate, which just puts another character or like another text in after this. So here we are trying to make a list of everybody in that all the names, and I'm adding your mom into the mix, and this is the outcome. Well, this is pretty obvious because we know how it works, right? In here, there's a list of 11 values, right? In A input of this one, and in B there's just one thing in that list. So if we are connecting list of this length and this length, everything in here gets copied like this. So everybody gets to be together with your mom. And when we make this example a little bit more complicated, where we have this list, where there's all the names with plus, and then we want to have your mom and your dad in the mix, well, the problem is that it happens like this, right? The first is index 0, so N and your mom are on the same line. And then, since there's index 1 over here, Buck goes with your dad, and then your dad gets like copied over the whole list. So if we want to have all the pairs, like all the possible solutions, we have to use data tree to make sure that we have a list of your mom and your dad for everyone. So like, bear with me, it's kind of funny, but we're gonna have to use the data tree for this. So in here, there's the normal list, and when I use graph on that, we've seen that, right? We've seen this. We know what does it mean. And there's now many lists, like there's N on index 0 on a list called 0, 0, and there's another list called 0, 1, and there's only Buck on index 0, and so on. So when I use the plus, well, you know, it's the same thing because it just adds plus because there's just one piece of data here. See, normal table. But when I use this now, the situation is quite different. So in here, there's many lists, and there's just one list, right? And this list has 2 indexes on there, and every single list in here has just 1 index. So the result is always the name twice, and your mom and your dad. So in this case, we have all the possible solutions, all the possible combinations, and it's actually separated in, well, Grasshopper calls it branches, data branches, because it's data tree, so it has branches. So it's separated into a branch where it's Anne with your mom and your dad, and then it's Buck with your mom and Buck with your dad, and so on. So let's jump into a more visual example, but I believe this could be helpful to somehow see what's happening with the data. So this is a longer list now, and that's why index 0 and 1 gets repeated over here, right? 0 and 1 instead of just 0 over here. So let's jump into something more useful, and let's see how this works. So I'm gonna go into a new file. I'm gonna zoom to somewhere, well, yeah, whatever. I'm gonna jump back to shaded maybe. Oh yeah. And let's try to emulate what this component does. So we have a component square grid, and we're gonna be interested in the points. So I'm gonna add in points like this, and we want to build our own square grid creator. I'm just gonna drop in bifocals so that you see the names. Okay, so what we want to do is exactly this thing, and since it looks like the size is 1, it jumps just 1, well, in this case it's meter, so it jumps 1 meter, and then there's another point. So I'm just gonna resize my view here, maybe like this. Okay, cool. So let's build our own point generator. So I'm gonna put in the point container, construct point. And then, well, I'm actually gonna hide this for now, maybe disable. And if I want more points than just one with 0, 0, 0, what do I do? Type it into commands maybe. What type of component do I need for this to have more than just 1 point? Maybe on the x-axis first. X-axis. Just to see that it's alive. So still no comments. Series, perfect. Yeah, I'm also yeah, agree. Series is the best one because it just, you know, by default the n is set to 1. So yeah, we're doing the xy plane. Yeah. So over here we have some points in the x direction. That's awesome. And what happens to a lot of users, you expect when I do this, when I go from well, let's do another series. And when I connect this to y, you always hope that there's going to be a grid, but there's no grid. It's just diagonal. And in understanding what is the problem here, we're gonna learn about like how to work with the data tree again. So does anyone of you quickly can know how why is it a diagonal? Why it's not just a square grid like we've seen over here? Why is it a diagonal? That's a question, but maybe just like, I don't want you to type all that stuff, so let's look at it first. So in here we have a list of numbers, right? I'm gonna take a panel here, and this is how it looks. You know, numbers, quite boring. Kind of. Yeah, something like that. Lakira. Okay. So in here we have these numbers. In here we have actually the same numbers. But the problem is when we put all these numbers together in a component, well, index 0 goes with index 0. And that creates, well, the first point, right? So I just want to make this super clear. So I'm gonna make a screenshot here. I'm gonna go to Paint, App. I'm gonna place it inside, and let's see if you can see this. So up, here we go. Up. Yeah, it's not working. Okay, wait, just a second. Now it should be there. It's not there. Oh yeah, it's there. Perfect. So now I can paint. And what I wanted to draw is like, check out the X. We're gonna use red for X. So, you know, X was 0. So that's why we have 0 over here. And then we have another input. Let's do Y in green. And we have this 0 in there as well. Well, that's why we have 0 over here. And when we follow the normal data structure of Grasshopper, we just do this for every single index. So the output is still just from 0 to 9, I mean 10 points, and there's no grid. And since the numbers are same in the first thing, in the first list, in the red list with the X, and in the Y list in the green one, well, the numbers are the same, and that's why it looks like a diagonal. So in order to make this work properly, I'm just gonna hide the drawing. Okay, now it should be live again. Where we go? Here we go. Yeah, does it work? Yeah. We're back. So in order to make this work, we actually have to make, for every single zero here, we have to do all these things. And we can do that by using graph. So right now, look at this list. We have 0 on the y coordinate, right? And it's only 0 because this first list named 0, 0, 0 was very short. And we are connecting it with a list which has a lot of indexes. So that's why we have a lot of x numbers over here and still the same 0 coming from here. So I can do the same thing. It's quite slower here, but I really want you to understand this. So in here we have like all these numbers, right? And the x input. And that's why we have this numbers over here. And similarly, if I go to green, we have just 0 over here and just one index, right? There's just one thing in this list. And that's why this gets copied, like we discussed. So is this a little bit clearer what's happening in here? Because without the graph, it's totally different situation. See? Just the diagonal. But when I grab this, I have a grid. So if it's clear, just type something into the commands. If you have some questions, let's ask them right now. And if yeah, it's clear to some. Cool, that's great. Awesome. So let's continue with this. Let's have a curve, maybe. I have two curves here. Perfect. Cool, guys. I'm gonna save this just for. Okay. Cool. Okay. So let's create two curves. You can go to Rhino. There's this curve command. Just click and make a few points. Let's create one curve. And I'm gonna reference this curve over here in Grasshopper. So just a curve component, right click, set one curve. There we go. Okay. I'm gonna make a copy of this and well, we're gonna do that later. So okay, I have this curve here, and if I use divide curve, I can get many points of there. So my output is a list of points, right? So it looks like there's 10 points in there. They have different x and y coordinates. Perfect. But what happens if I create another curve container and I reference both curves? So I right click, multiple curves. Now both curves are in here. When I connect this, I have the dashed cable. See that? Because these are all the points for the first curve. These are all the points for the second curve. And this is how you can create, like, something kind of more interesting than this, boring grid, because this is also a grid, right? We have x direction and y direction is actually from first point to second point, like this. So if we had more curves, we can have a more interesting grid, and still it's gonna have the same data structure like this, right? So this is the moment where you start thinking about not only the geometry, but also the way the data is structured, because sometimes You don't know if the points are structured along the curve or, you know, in the opposite direction. And in order to see that, let's try to play with this very simple example. So I have this 0 index over here, another 0 index over here. So what happens if I use list item? So I'm gonna keep this down here. And if I use list item with index 0, my output is gonna be just 2 points, right? Because there are 2 branches of data, so it picks the index 0 from both. And this can be sometimes very useful, and sometimes it can be very misleading, because sometimes you don't know how the data is structured, or maybe you're not sure. So I always take this list item, put it in there, and see what's happening. So in order to make this visually visible, let's use polyline to actually make a straight line coming from these 2 points from one to the other. So in this situation, when it's still separated like this, we have a problem because there's not enough points to make a polyline, right? We have just 1 point over here, and then there's a different story, and that's the branch called 0, 1, and there's another point. So in order to make this work, we have to get rid of the data, and data tree, I mean. So I'm just gonna make a little flatten component here. Of course, you can later on do it with just the arrow when you right click, but in this case I want you to see the difference. So this is when it's the data tree, dashed cable, 2 branches, it doesn't work. But when you flatten it, it goes into a single list like 0, 1, and now its index is over here, so we can create this polyline. But sometimes, you know, the points can be ordered along the curves, not like this. So in order to flip that, we can use flip matrix. And that's sometimes very useful tool. So try to remember flip matrix. Because what happens after flip matrix, I'm just gonna make a maybe copy of this. Okay. Delete this, keep a copy but disable, and over here I'm gonna use flip matrix before the list item, and we're gonna see what happens to the data. So in here I have a lot of points, and when I do flip matrix to those points, check out the data now. Do you see what happened? Instead of having 2 big branches with 11 points in there, I now have 11 branches of data, and there's always 2 points inside. So when I connect this to my list item, that curve goes, see, like this. It's a totally different thing. So flip matrix goes and makes a branch out of indexes. So there was index 0, so now we have branch 0. There was index 5, so now we have branch 5 over here, 0, 5. And this is how you can quickly change what's happening in your grid and so on. So let's try to use flip matrix maybe in a more concrete context, and that might be the grid over here. So I'm just gonna recreate that because this was just for explaining. So disabling that, going back to points, construct point. I'm gonna have just 1 series this time, and I can do this. So it's the same situation like last time. I just made it faster. So you create a series of numbers, you use them as X and Y, but one of these two inputs has to be grafted. So right click, graft. So now we have this grid of points. I'm just gonna zoom into that, and let's try to play with this grid a little bit. We've learned that branches have some names. Grasshopper called this a path, which is somehow crazy, but it's called the path. And we can actually select these things. So let's say we want to select just one column or one row in here. There are two ways how to do this. One is our trustworthy list item, and I use this list item on this. Let's give it index 3 maybe, or something. I don't know if you see it properly, but now this row or this column is green, and I can move it this. It looks like we've selected it properly, but the problem is the data is still separated. If you look at the data over here, you know, we have all the points in our selection, but each one is in a different branch. So this probably, when I want to make a polyline through this, won't work, right? When I give these points into a polyline, it still doesn't work because they are on separate branches and they are not connecting. If I flatten the data over here, I should have a line over here. Now it's a line there. I think it's time to hide the grid because it might be confusing a little bit. So just gonna type grid in here. Yeah, like this. Okay. So now I have the line, but I got rid of the data tree, and that sometimes can be, well, pretty how to say it, like pretty bad, because you lose the data structure. In some cases it's easy to get it back because it's still in the same order, but most of the time when you want to select something out of the data tree, it's easier to use the component called branch. So I'm gonna put in this tree branch thing, and we're gonna try to do the same thing using the branch item. So delete this, and this tree branch is a kind of strange component because it asks for any kind of data in T, and then it wants the path to that data. Again, path means this names of branches. So this first branch is called 000, and the second one is called 001, and so on. In order to simplify a little bit, you can always, as you have an input, you can simplify the names of branches. And since there's no difference in there's no not so complex data, it can be just one number in brackets. So let's check out this branch item. Let's try to select one, and this is going to be a row in this time. So I'm just gonna type this, so it has to be like this, curly brackets and one number inside. I have curly brackets, and this selects, okay, this nice row of points in here. I can do the polyline now, and it's gonna work right away because this branch is just a list. Let's see that. See, it's just a list, so I don't have to do flatten. I don't lose my data structure by flattening the data. I just have a list, and this is the sixth list. You can compare, it's the same one. Of course, it has number 6 over here. So this can be useful, but sometimes your data tree can grow, and you have to change this. So maybe it would be nice to have a slider over here. And of course you can do, path, construct path. So this little component just puts brackets around the thing, and in here you say index. So if I say index 6, like a slider, I put it over here, I have the same thing and it works. So it seems like the same thing with list item. It's just called branch. But what do I do when I want to select a row? I mean a column, not a row. Gonna make the panel width 6. Yeah, the panel width 6 is, again, you do 2 slashes and then type whatever you want to have in there. So you have to type two times this thing, two slashes, and then that the thing you want to be in that panel. So 2 slashes and whatever you want. That's for Aaron. Okay, so yeah, cool. So this way it's kind of useful. We can go to the end, but when we exceed, this breaks because there's no branch called 0. Called 10, right? So the problem is that we don't know the maximum over here, and sometimes this can be a source of big trouble for other parts of the script. You get null data or something. So what I kind of see as a good habit, I'm gonna keep it in there, is to use this component called param viewer, because, well, I'm gonna do another copy over here like this, disable that, and this param viewer is a cool component because if you give it any data with data tree, the output from there is the names of the branches. See that? So now we have a list, and that's kind of funny, and now it's getting a little bit inception-y. So this is a list of the names of the branches. So maybe if I don't simplify, see, this broke because I'm just putting in there number 7 and there's no branch called just 7. Now the branch is called 0, semicolon 0, semicolon 7. So in order to keep your names of data branches or the path, in order to make them work, I always use this param viewer. And well, now it's a list. So we know how to pick things from a list, right? So I'm gonna use just list item. And now we're back to the same thing we already know. So I'm gonna clean it up a little bit over here. So this is my names of branches. I'm gonna select one of the names, maybe on index 6. And then I'm gonna feed this to my branch. And now it works, right? Because even if my data names, the names of the branches, if they change, I'm just selecting from a list. So this is safe to work with. So now my tree branch is working properly, and still I can use the line in there. I can select this like that. Cool. This I always call I call this the branchator or something like that, because it separates data in your branches, and it's kind of useful. So I'm gonna just give it a beginning with a generic component called data. So I'm just gonna say that everything, Control Shift, everything in here should be coming from this part. Just gonna clean it up a little bit, and this goes a little bit further. So when I connect the data in, I have it working like this. But we still didn't solve the problem that we wanted to select not a row but a column, right? And initially we did it with just list item, and sometimes it worked, but you lose the data. So this is a nice example when you want to flip the matrix. When you want to have a column instead of a row, you just put in the flip matrix. I'm just gonna move this a little bit. Damn it, sorry. Oh yeah, that's it. So I have this order of points. They are separated in rows. But when I do flip matrix and connect this, now it's columns. And this is very helpful. And also if you run out of numbers, using this list item thing, there's this wrap option, remember? And if I say 10, it selects the first one again. See, we're back on the beginning. So this can be helpful not to break your data if you cycle through some longer sliders. So this is the case with the data flipped, and this is the case without the data flipped. And I hope this somehow makes sense to you, because this is very useful. It doesn't have to be a grid of points like this. It doesn't have to be flat. It's gonna work on any kind of thing like this. So right now I think it's time to test this on a different situation where we're gonna have few curves like this, and our grid is not gonna be boring like this. So let's make another example, and this time we're gonna start with the surface. So I'm gonna create a surface. If there are no questions, actually, if you have questions, maybe now it's a good time to type them, and we're gonna continue with the surface. Any questions out there? Okay, seems like not. I'm gonna pause if there are any. So let's jump into Rhino again, and there's this command called 4-point surface. It's actually called underscore srfpt, surface points. I'm gonna click, control click, and control click again to make a surface which is curved a little bit. It's a little hyperbolic surface. And what I can do is, now it's in Rhino, I can type the command rebuild. Very cool command. You can rebuild with, well, 10 is too much, but let's say 4 times 4. And let's keep the degree to 3, because this is going to be now a totally different surface. Because if I turn on the control points using F10, I can now select this point, and I can just, move it up. Where's the other points? There's another one over here. I can move it down, maybe like this. And I can also make the edges a little bit more interesting. So this part is going to be like this. Just make it a playful surface. So 4-point surface and then rebuild. I'm just playing with the points. Yeah, this is something like nice. This one is gonna go down as well. This one is gonna go up. Yeah, and this is still a straight line, so I'm gonna go down with this one and up with this one. So now I have this nice surface, and we can use this to make a more interesting grid than we had before. So just a surface like this. I'm going to select that surface, right click on my surface in Grasshopper, set one surface. I kind of hate this, two things on top of each other. So what I'm going to do is go to, double click. I'm going to go to wireframe. Or since I don't want to change much about this surface, I can actually stay in rendered, but I'm gonna just hide that surface. Okay, shade it maybe. Okay, cool. Are you with me? I do have a surface like this. Okay, so what I'm gonna do now is divide surface. That's pretty simple thing. And that's gonna give us a grid. See, now we have a grid on that surface, and everything we've done over here on this regular grid will apply over here. So let's take the points and see, this is now data tree. I'm just gonna do a point container over here, and you see that it's data tree. Let's put a panel in there. So this is how it looks. See, there are many branches with some points on them. This is what we know. So I can actually take my branch shader from over here. So anything on the start, this param viewer, slider, list item, and a branch. I'm just gonna make a copy of this using Alt. And this is how I can select just one. In this case, this is the rows, and I can actually flip this to be columns using flip matrix. So if I flip the matrix, this doesn't do anything with the points. It just reorders the data tree in there, and now I'm selecting a row instead of column. So I can do a polyline again, so that we can see that it's like this. And if I don't flip the matrix, it's like that. Okay, this can get kind of boring, but there's more interesting things ahead. So I'm just gonna make a copy of this whole thing again. Here we go. Disable this. And in this case, I want not to have just just one line. I want to have more. So I'm gonna use series in this case, and I hope you already know this trick, but it's very useful. So I want to start at number 4, and I want to go all the way to number 7. Oh, sorry. I want to have 7 things. It's maybe too much. So I'm gonna have 3. And this by itself, you know, the series generates numbers, right? And I can use them as indexes. So 4, 5, 6, those are my indexes I want to select. Now I have 3 curves on there. And the important thing is they are still separated into lists. So if I use a panel again over here, you can see that we have a list for the first curve, a list for the second curve, and for the third curve. See? So they are not connected, the 3 curves are not connecting together. And that's actually very useful because sometimes you really don't want this to happen. If I, on the other hand, were to just flatten the output over here, I'm gonna have these awful diagonals going down here. And well, most of the time this is not what you want, right? Okay. And there's one more thing. What if we wanted to connect, okay, no, I'm gonna first show you something cool, and then it's gonna be like your task that's better, so that you start playing with this, not just copying what I'm doing. So let's keep this part again, make a copy. I'm just gonna hide this. I'm gonna use the points right away like this, and there's this very cool component called split tree, and that's actually a very powerful component. It has many uses, and let's check him out because you can do all sorts of things with this. To understand, there's this like data input for any kind of data tree, and then there is something called mask. By default, if you stop your mouse over the M, you're gonna see that this is supposed to be text type of data, and this is supposed to be, you know, the names of branches which are gonna mask your tree. Sorry for this. So if I have this data tree over here, let's look at it like this. It seems like the names of my branches are like 0, 0, 0, and then it's going to be 0, 0, 1. But I want to simplify this so that it's just 0, just 1, 2, and so on. I can easily just do a list again, a panel again, and type maybe 5. And this is going to select just these. So I'm going to put a polyline on that again. And we still have the negative. And that's sometimes very useful because we're just, separating those which we want by selecting the name of a branch, and those which we don't want are still there in that data. We can later on we can put them back together, and this is very useful. So I'm gonna put a small sphere, mesh sphere, because mesh spheres are faster, and the radius is gonna be super small, so 0.2. So something like this. Oh, okay. 0.5. Yeah. So now I have spheres on all the points I don't want, and I'm making a polyline on the one I selected. Well, you could do this with our trusty branchator, all this thing with bar viewer, list item, and tree branch. But this one is really more powerful. So check out what it can do. If you make another panel, and let's do curly brackets again, we can actually put in some how to say this, we can use something as a series in here just by providing the indexes. So I'm just gonna show you. So I'm gonna type 1, comma, 3, comma, and then I'll do 3 dots, and that's it. It looks like this. And when it has to be curly bracket. Yeah, like this. And when I connect this, I'm gonna have a separation of this data tree into lines and spheres based on the fact that I first select my index 1, then 3, and then it continues. So 1, 3, 5, 7, 9, and it goes along the whole list. So this way of saying what you want is much more faster than using the branchator with a series or something like that. And you can also make a similar thing with saying stop at number 7. So if you, after the 3 dots, do another comma and say 7, this will exclude the number 9 from there. So that means we can actually do all sorts of patterns with this, and also there's this cool feature that I'm gonna make another copy of this. I can also ask for an index. This is almost like in Python. If you do square brackets and you just ask for index 5 like this, we're gonna first filter the branches to all the odd numbers like 1, 3, all the way to 7, and then we're just gonna ask for index 5. So when I connect this to that one, see, I'm only operating on index 5 like this, these few points. The 7th branch is not selected, and this is very cool for selecting different parts of your data tree. And you can do the same trick in also in the branches, I mean in the lists. So over here I can do 5, 6, 7, and I'm gonna have 3 indexes per each. So if I connect this, I'm just gonna have these short lines over here using the indexes I've just put in. Or we can also use this thing with the three commas. So I'm gonna start with 0, then comma, 2, comma, 3 dots. And that's gonna be another cool example over here. In some cases we have 2 short lines in there, but if we look at the output, in those places where it's not selected, there's this weird thing called null, and in those places where we wanted to connect that, there's like the data. So we can get rid of those nulls by clean tree, but most of the time this is useful because you can see the empty data on those places where you didn't select the thing. So split tree, very cool thing. Is it clear? Great. Okay, so I think I remember one cool video about just this split tree component. So I'm just gonna reference this after the lesson. I believe it's from David Rutten, the author of Grasshopper. So it's like from the boss. So you're gonna check it out. There are some other features with asterisk and exclamation mark or something like that in here. So it's even more powerful than this, but these things are very useful. I use them all the time. Okay, one more thing we want to do with data tree a lot of times, and it can be confusing. So let's jump onto another example here. So I'm just gonna disable this. Let's create 2 closed curves. Like 1, 2, 3. I'm just gonna do a blobbish curve. So this is my first closed curve, and I'm gonna move this one up, hitting Alt to have this plus button, and now I'm gonna change the points a little bit. So I'm gonna say this one goes over here, this one goes over here, and this one goes over here. Yeah, quite different shape. Maybe this one goes over here as well. Yeah. So my plan is to do some freeform loft out of this. So let's take those 2 curves, right click, multiple curves. We have 2 curves, and I'm gonna say loft. So over here we have this cool lofted shape, and let's again assume that this is a skyscraper, and we want to have all the floors in there, but then we want to separate those like we want to make a facade for each floor separately. And that's again somewhere where we need to use data tree, because this is most of the cases you just create a lot of curves, then you love them, and you have like it looks like okay, but sometimes if you want to have different framing per each floor, this is the case. So I'm just gonna have this surface over here. I'm gonna use contour for this shape. And so, well, the point 0, 0, 0 is kind of okay for us. The direction is 0, 0, 1, that's okay. And the distance, I'm gonna say 4 meters, 4.5 meters, something like this. When I provide the D, it slices it up, and now we have all the curves for every single floor plan there. Okay, that's a lot of curves, and I can hide the loft now. And let's say that now we want to make a glazing just for the first floor, and then stop, and then another glazing just for the second floor. So we need data tree for this. So I'm gonna take all the lines I have and use shift list. Remember shift list? Oh, not loft, I mean all the curves here. And the funny thing is, this separates it into data tree. In this case, we're just gonna flatten this so that we have a list and we can operate on this list pretty easy. And you can see that the last curve is now missing. And that means all these curves can be the starting curve of a glazing. So I'm just gonna type it into its name. So starting curve, all of them. The thing is, I really want to get rid of the wrapping, so I'm just gonna use a toggle to say that wrapping should be turned off. And just for visual purposes, I'm gonna say that this is shifting in the positive direction, right? So all the starting curves, see the last one is missing there. It's not in the list. And then I make a copy of this, and I'm gonna say that this should be shifted in the negative direction. When I select this, oh, really? Okay, 0. Oh, okay, -1. This is funny. Okay, funny. Let's see, but this should be the ending curves. Sorry, ending curves. And now we want to make a loft from the starting curves, like from every single curve in here. I think my preview is you know, weird, but let's see that. If I do loft now, you know, this is the. Oh yeah, I can get it. The first one is not there. Okay. Sorry for this. I'm just gonna lower this point a little bit. Yeah. So now these are all my curves. I can hide these. Okay. So these are all the curves. These are all the ending curves, and these are all the starting curves. Yeah, sorry for this. My point was actually on the exact start of this surface, and this is what happens if that surface starts at 0 and the point is at 0. Sometimes it's there, sometimes it's not. So I'm sorry for this. So these now it works nicely. Just gonna hide this as well. Okay, so these are all the curves. And now I'm using all the, well, these are ending. So, ending curves. And these are gonna be the starting curves. I mean, like, every single floor has its facade and its glazing. And if I use the loft for this, these are the bottom curves, right? It goes from bottom to up. So these are all the bottom ones and these are all the top ones. But the problem is when I connect this together, well, it either crashes, or if I use merge to give it some order, so first the starting curves, then the ending curves, well, my loft is gonna be also confused because there's a long list of curves. What I want is a short list where there's just first curve and the second curve. and this list stops, and then the second curve and the third curve, and the list stops again. And I can actually make this work by using data tree again. So see this long list of curves, all the starting curves. If I make a graph, like I'm just gonna disable this so that it doesn't crash. So if I make a graph over here, if you look at the list over here, you know, there's like a lot of curves in here, but then seems healthy. There's just one curve per branch. So that's cool. And if I graphed it over here as well, now we have what we wanted. 2 curves per branch. See? So if this data gets grafted, it's just one curve at a time. Maybe what I'm gonna do is I'm gonna graft it over here instead. So graft, I'm gonna get rid of these guys, and this is what I've got. So just a long list of one curve per branch, another long list, one curve per branch, and since the names, this is 0, 0, 0, and we have the 0, 0, 0 in here as well. If the names match, then the merge puts it into one list. And then we can actually use the loft, make it work. So right now, I have a lot of lofts, and I can use, you know, I can do different things to each floor in there. I know it's not visible, but when I bake it, you're gonna see the difference. So I'm just gonna bake it in this layer, and see that we have this layer, and this layer, and this one, and this one, and so on. So to make it visible, I'm not sure if you have this Lunchbox plugin, but it has this cool paneling things, so we can do random panels and use each surface for random paneling, or we can do anything with these things. So in here, let me just make sure it's all untrimmed surfaces, so we can do all sorts of things with this. So I'm just gonna delete this, I don't need that. So this is a thing which comes, which happens many times to a lot of students. Like you have to do the shifting in lists, and then you have to graft it in order to make sure that you're connecting or lofting the right things together. Let's try to do, yeah. Okay, I'm gonna do these panels here. Maybe random panels, surface, and I just want to see that U is gonna be just 1. And V is gonna be many more, so let's say 50. Okay. So now it seems like they are all the same, but the problem is, again, if we have a data tree in here and we want to have 100 divisions per each layer, the problem is that this seed has to be different for each one. So we have to calculate how many lofts we have. It seems like 24. So I have to do list item, list length. So here's list length. And again, if I do list length for the data tree, the output is gonna be, well, not much useful, right? It's gonna say 1 for each branch in there. But if I flatten it first, it's gonna say 24 because I have 24 surfaces. And if I want 24 different numbers, let's just do series. Now we're gonna have 24 different numbers, and I can, if I plug it right there, it's gonna probably crash, because again, this would happen 24 times for every single surface. But if I graph this, I have a different number for each surface here. So when I connect this, you have random panels. I just realized maybe it's not so smart to do something with a plugin, which I didn't say beforehand that you should download, but Lunchbox is very super useful with these like quick panelings. So check it out on Food for Rhino. I'm gonna put a link into the file, so that once you download it after the lesson, you're gonna see where to download this plugin. I just wanted to show you that sometimes when you connect, when you have data tree and you connect something which is not data tree, it's a list, you can get into real big trouble, because you know those things can multiply, and you're gonna have, you can even crash Rhino with this, like, or you know, call for a computation which would take like 7 years or something like that. So you have to kill the process and start over. So I'm gonna save this because I don't want to do that. Okay, how much time do we have? Yeah. Okay, I think we can do one more example with data tree, and it's something we already touched on a little bit, but I think it's a good exercise. So I'm just gonna disable this again. This time I'm gonna use these two curves I have over here. They're on top of each other. It's like a facade. So I'm just gonna reference those two curves. Right click, set multiple curves. I don't like the points. I'm just gonna hide this as well. And also this. Okay. So back to these two curves. I'm gonna create a loft again out of them. So now I have a surface. It's curved a little bit. It's gonna be another facade like we did with the sun, but this time we're gonna be a little bit less technical, more creative, because we want to see the how to work with the data tree when it's too complex. Loft only work with closed. Okay. There's a command that the loft couldn't work with open or closed curves. Yeah, that's actually true. It seems like one of your curves is not closed, or one of your curves is not open. Like all of them have to be open, or all of them have to be closed. So maybe if you created those two curves in the beginning, one of them was actually not closed, so you make a new curve and make it closed. If your problem persists, just send it to me in the Grasshopper file, please. Okay, so let's get back to this thing. We have this loft over here, and I'm gonna do this isotrim division. I hope you remember it a little bit from last time. We've done this still at faculty. So there's this surface over here, and we want to divide this surface into little rectangles, and we're gonna use divide domain squared. I can feed it the surface right away, and I can feed this domains over here in the isotrim. We're gonna touch on that once more in the next class, when it's gonna be all about local coordinates. But now we have some divisions, some you know, untrimmed surfaces, some rectangles, and you know, the output is still a normal list. See, so nothing fancy, just a list. But when we use brep explode, or yeah, okay. Sorry, deconstruct brep. And we use deconstruct brep, this guy, the output from this is already gonna be a big data tree. So there's gonna be faces, like the surfaces themselves. There's gonna be edges, 4 edges for each one, right? Kind of makes sense. And then vertices, 4 points for each one. And this can get sometimes pretty confusing when you're working with a lot of things in this huge grid. So this little like approach helped me many times. So I'm just gonna drop in a list item, or before that I'm just gonna use point list. I'm just gonna give it all the points, and I'm gonna say that the size should be, I don't know, 2. See, the numbers are all overlapping, and it's awful, right? You can see that they are from different branches because they have different colors, but it's a mess, right? It's too much data and not enough space. So in order to make this work nicely, I always use this approach where I just filter just one surface out of this. And now you can see that it's pretty simple and clear, and you can see that 0, 1, 2, 3, those are our points, and we can do things with those things. And then we just bypass this component here, and it's gonna work for all of them in there. So I'm just gonna select someone in some piece in the middle. So I'm gonna just say well, 12. So that's this guy over here. That's cool. So we're gonna work for a while on this, just 4 points, this one little surface, and then we're gonna make this connection proper for all of them, and hopefully it's gonna work for all of them. So this is something you can do as a little exercise, because it's always fun to do things. I have this 4 points, and I want to use list item to select all 4 of them. So if you zoom in closer, you can have 4 inputs, 4 outputs, and you can use all four of these points to actually do things. So maybe let's create something very simple. Maybe we can do like a pyramid, and then it's up to you what you come up with, and just upload some nice pictures to the blog. So how to do a pyramid? There's a very quick thing you can do with points. You can use average to have the center. So I'm gonna use this one, this one, this one, and this one. And now we have this point in the middle, because it's just averaging all the x as y and z of all these points. And we can do extrude point. So this is gonna be the point. And well, we can use this face for the extrusion. So when I now make the connection from here to all of them, I should have all pyramids everywhere. Maybe this guy is not needed anymore. But they're actually a little bit boring, because the middle point is not moved, right? It's just in the middle. So maybe instead of doing that, it's time to pick a point on the middle of that surface. Just one thing to make sure that everything works. In here, this is where our data tree gets created, and just a good habit is if you know that some component creates your data tree, don't try to connect things from here with this, because if I did, like, you know, these are the surfaces and these are the surfaces as well. But if you did, it's gonna crash again because there's like 100 middle points, and if you provided a list, not data tree, that would be 100 times 100, which is 10,000 different. I think this is gonna be healthy. I'm just gonna save my file if it crashes. But if I do this, okay, I'm gonna lower it so it's just 5 times 5. Then it's not gonna be that problematic, but you know, you can really crash the thing. So now it's 5 times 5, and when I do, like, this is with the data tree, so it's fine. But if I do, you know, these surfaces from here to there, yeah, see? Okay, this is gonna be awful. See what did it do? Now I have a list, so all these surfaces, each one of them will go to all those 100 points or 25 points. So I have many duplicates. It's awful. So make sure that you always connect data tree with data tree. Otherwise you can get into trouble. Okay, so I'm gonna say 10 again in this direction as well. Maybe a little less in this direction. Yeah, something like that. Okay, so the thing to finish with is gonna be, let's make a middle point on all of these surfaces. So again, I'm gonna take these surfaces coming from here, and I'm gonna ask for the middle point using evaluate surface. So this goes here, and the UV, we can use the multi-dimensional slider, like MD slider, for that, because it's by default it's 0.5 in both directions. I can just make it smaller, and I can just plug it in. And there's one little thing, we're gonna touch on that next time for real. But in here, in the S, we have to go to reparameterize. So all the surfaces go from 0 to 1, and that's why this position of 0.5 is actually always in the middle. So now I have the middle point, which we already had from here, but now I have more things, and one of them is the normal vector. So I can take my middle point and I can move that middle point using the normal vector. So let's do that. I'm gonna take this point and I'm gonna move that point. So I'm gonna move that point using this vector, and I want to multiply it by some number or maybe some attractor. That's up to you. So I'm gonna say 5. Okay, 4. So now we have the vectors. We can move the points using them, and yeah, it's on the opposite side over here. And now we can actually use these points instead of the original ones for the extrusion. So I'm just gonna use these points over here. Now I have nice huge pyramids. Again, this should work for just one. So if I just disconnect this, you can see that you can work with the easy things without the data tree. Make sure that everything works. You know, when it's nice and readable, you can change the positions also, or other things, and then you just reconnect the whole list, which generates the whole data tree for you. So I believe this is time where we can do custom preview, right? Give it some nice color. Nice, I said nice color. Okay, it's gonna be this kind of color, and I can switch to rendered. So, ta-da! And maybe like when you're in rendered, it's time to hide everything else. than just the preview, so that it's not awful. Okay, so this is the way I work with data tree. Sometimes you can get into trouble when you do too many times the list item, because when you put in data tree, situation can change. But I would be really glad if you try to do something more interesting than just a pyramid. Again, try to do it with just one piece first, and then after it's done, try to feed it the data tree. If you get into trouble, I can help you, but this is something you really have to experience, because sometimes while doing these things over here, you maybe use data tree as well, and then when you have one element, it works, but when you put all the elements in, it's like 2 layers of data tree. That's maybe something I want to finish with. It's in the file we started with. Yeah, in here. The data tree is very powerful and can have many layers. So in here, that's just for like understanding. You don't have to make this. I have one series, and I just create that these numbers are the starting numbers of another series, and this generates some nice data going from 0 all the way to 9. Then it starts at 1 all the way to 10, and then it starts at 2 all the way to 11, and it generates this data tree, which has like normal structure. See that? Like first branch is called 0, 0, 0, second branch, third branch, and so on. Over here it looks like this. There's just one big branching, and that's it. You can double click to go to the other view, and that's how it looks. But if I connect another series, maybe I'm gonna connect it into C this time, my data tree gets really confusing. So in the first branch there's no data, because, well, I said there should be 0 data in the first branch, right? Then there's one little series in the second branch, and then there's another series which looks almost identical, and then there's like 2, 1, 3, 0, and if you look at the names of the branches, it can get really complex. So in here it's like 0, 0, 1, 0, 2, 0, 2, 1, 3, 0, 3, 1, 3, 2, 4, 0, 4, 1, 4, 2, 4, 3. You can see the pattern, right? And this is how it looks visually. So your data tree sometimes can look like this, and it can get really confusing when it's too complex, so try to keep it as simple as possible. But sometimes there's no other way. Maybe you're working with something and some elements actually fail to do a boolean, so you have to replace them with something else, and that something else gets created and use data tree on the way. And this is how you can get really complex data structure. And when it's like this, it's always good to try to work on the whole data tree, where every single piece of data is the same type of data, because then you can still make connections even though the data tree is complex. Maybe sometimes you have to filter the data tree, maybe do this just for some, but never try to make data trees which contain different types of data, like maybe a text and a number, or a geometry and a number, or something like that. So this is like a reminder, like with data tree you can do all sorts of things. It's actually something like a nested list in classical programming, but in here it's all ordered like on top of each other, so it doesn't look that much nested. But this is a nice approach how to see that. It's like the first branch is called 0, 0, and it branches into 10 different branches over here, and then each one of those can branch again into many or like in this case it branches into 7 other things, and this one branches into 8 other things, and this one into 9 other things. Can get really confusingly complex. Okay, I'm just gonna go back to our example. So maybe now it's time for questions again. I'm gonna take this file, make it a little bit nicer, and upload it again with some pictures. I'm gonna reference some other tutorials on data tree, and definitely if you still didn't read that part in the book, go there and look at it. This needs practice. Like if you understand everything today, that's perfect. That's great. Like you're smart. But it needs practice. So definitely check out that book and definitely maybe look at the other tutorial I'm gonna upload. Yeah, that's it. Maybe that's it for today. I didn't receive any emails with you complaining about the method of teaching. Right now, I can see that there. I kind of miss your feedback. So, um, I'm still thinking about moving this to the teams, but the book is listed on the first lesson, and yeah, I think I'm gonna put it everywhere. But if you go to our website and there's this first like start of the semester, there is the book, or just type mode lab primer Grasshopper into Google. So I didn't receive many of you like complaining about the way of teaching here, but since there's only 11 or 12 of you, I'm not sure if everybody is attending these lessons. So if you know about someone who is missing these classes and should be here, let me and him or her know, because I think there should be more people than 11. And yeah, so if you have questions after looking into that book and after checking the tutorial, just send it to me in a Grasshopper file. Don't forget to reference your geometry. Yeah, there's a question. If you get lost at some point, well, now you have to describe that point. What if you posted a comment of at that point actually? The XYZ moving tool in Rhino. Oh yeah, it's called Gumball. It's down here, one of the buttons. Yeah, if you click on this, this gives you the Gumball. So I don't have, yeah. So this enables that. Yeah, I kind of like it. It's very useful. It has its own menu. If you left click this white thing, you can relocate it to some other place. You can align it with object or with some world axes. You can do smooth or snapping, like grid snapping with moving with this. And yeah, you can actually have different strengths and there's settings for it. The other thing about it, you can use this to move. You can use this to scale. So I'm gonna scale this in the right direction. So when it's like open box, it's for scaling. And there's this little circle tool. I'm not gonna do it on this because that would change the type of geometry. That's just for Rhino users, but it can be useful for some quick modeling. So, oh, sorry. I'm just gonna make a copy here, drag, hit Alt, make sure that there's the little plus button. And if you have it like this, this sphere, this circle thing, it's extruding. So that's for very fast, modeling. You can extrude things like this, and you can even extrude surfaces with that. So you can. This is for quick modeling in Rhino. Okay, questions? Maybe more about the data tree, but yeah, I get it. Mm-hmm. On Teams, there is also recording, but yeah, I tried it, and it's it's Microsoft their own streaming thing, and it works, but I'm not sure if it's gonna be that useful. Because they have it on streams.microsoft.com, and you have to download the video, and I'm not very happy with that yet. But I kind of miss your feedback here. It's like talking to a screen, and that's not like I'm used to teach. Okay, other questions, please. No, or let's continue with this discussion. Do you know why there's only 12 people? Like, people are gonna say that we're gonna watch it later and then never watch it, or something like that, or like, I think the timing should be good. If you know about someone who should be here in the classes and is not, please tell him or tell her. It's better when you're here, because I can react on your comments at least. Okay. If you have other questions, again, send it to me. But first, consult the book. I'm gonna put a link to the book to the website once more, so that you can see it next to this lesson. And if there are not any other questions, I guess this is it for today. I hope you learned something, and hope it was not boring. One last thing. What about the curvature in the city? Did you solve it somehow? Were you able to solve that? Hmm? Oh, cool. Okay, I think I can show you, but I first want to know if somebody solved it. Okay, let me search for that file in the meantime. So here we go. Tried by configure out. Okay, so here we go. Okay. Yes. So here's my curve, and I want to see the whole thing. Oh yeah, of course. Shade it. Good. So here's this thing, and it looks like it's linear. Try to attach graph mapper. Okay. Slepinda actually figured it out, but only in Czech words. That's the right way to do it. So I'm gonna quickly show you. The height of the buildings is actually decided over here, right? Where we have the Z domain going from 0 to this number. And these numbers are coming all the way from, the important numbers, remember? In order to make this not linear, not just boring, we need to make something with the numbers. And as Slepinda suggested, we can use power over here. So I'm just gonna make this cable normal so that you can see it. So it's default cable now. Control Shift. I'm gonna connect it over here. And it's a to the power of b, and I'm gonna make a slider going from 0, 0, 0, 0, 1 all the way to 6. That's maybe enough. So if it's very small number, I'm gonna be actually making the square root of it, or even more root of it. Okay, too bad. Okay, Hansa actually solved it almost, but let's see how to make the boxes. So now the numbers are becoming quite different. If you look at the initial numbers we're feeding into the thing, they are becoming all kind of very small. See, there's very small difference, because if we you know, just do power of almost 0, it's like it's 1, right? Anything to the power of 0 is 1. But if we provide a bigger number in here, we can actually give it a different type of curvature. And since we still have this minimum and maximum under control, that's actually perfect, because we can use this afterwards. So first you decide on the curvature, maybe like this, and then you provide minimum, maximum. But make sure that this slider is actually bigger, because this can be very sensitive to like numerically sensitive. So on that place where you decide the maximum of the domain for the box, you have to use power in order to give this a proper curvature. So actually in cities, I think, like, you know, it's something like between 0 and 1. So 0.4 is quite okay. If you go over 1, when it's 1, it's nothing happens, right? Anything to the power of 1, it's just the same thing. And when it's something like 1.5, it's like sloping the other way, which kind of, well, in very strong central cities, this could actually be the case, right? But most of the cases, like, the center is where the prices are the super high, and then it quickly tapers off. So I think a number between 0.5 and 0 and 0.5 should be okay with this. And in some points you can get into really like problematic moments with, you know, this being like 0.001. You can see that it's maybe rounded off by Rhino, so you don't have much control over it, but it seems to work nicely. Okay, so did I answer your questions? Is it clear what to do? Can you solve this now? Because this is a very common thing with attractors. You just have to, you know, sometimes use power, and if you remap it afterwards, you are sure that those numbers are not crazy. They are always going to be from well, 10 to 0 or something like that. Okay, I hope this helps. If you have further questions, ask them now, or have a nice lunch, or whatever you plan to do. Breakfast time. Oh, cool. Yeah, I actually have my breakfast right here. Oh, you don't see it. Do you? Oh, yeah. So this is the thing I'm gonna have. It's apples in yogurt. Pretty awesome. I'm gonna stay for some more questions. Few minutes longer, but this is it for today. See you guys. I'm gonna check out the, did you do any suggestions of the topics, or did you not? Okay. Oh yeah. Okay, that's it. I can see there are not many suggestions for the topics, so I think I'm gonna follow with the table we've got. Um, so we're gonna focus on local space coordinates next time. It's the T, U, and V coordinates, the thing we touched on 2 times already. So I want this to be clear to you because it sometimes can be problematic. So we're gonna try to do another cool things with it. And that's it for today. So bye guys. I'm gonna upload the file maybe in the evening because I have another job to do right now, but it's gonna be there today later on. Cool. I'm looking forward to see some 3D printed bus stops. Some cool scripts. Okay. You can send it to me in the meantime by email. Just make sure you reference your curves and things so we don't have to send a huge Rhino file. Okay. Bye.